For centuries, gravity was understood as a force between objects with mass. Newton's equation seemed clear: no mass, no gravity. Light, made of massless photons, should travel in perfectly straight lines, untouched by any star or planet it passes. Yet it doesn't. Light bends around the stars, warps around galaxies, and can even be trapped entirely by black holes. How is this possible? Einstein's general theory of relativity provides the answer. Gravity is not a force reaching out and pulling on objects. Instead, gravity is the curvature of space-time itself. Massive objects like stars and planets don't pull on other things. They warp the fabric of space-time around them. As physicist John Wheeler put it decades later, summarizing the core idea of general relativity, matter tells space-time how to curve, and space-time tells matter how to move. But this still leaves a puzzle. If gravity responds to mass, why does it affect light at all? The resolution lies in a deeper truth. Mass is just one form of energy, and in Einstein's universe, gravity doesn't respond to mass alone. It responds to energy in all its forms. Light has no mass, but it carries energy and momentum, and that's enough. So, even though no force is grabbing it, light still answers to the geometry that energy itself helps create. In this curved space-time, light follows the straightest possible path available to it, what physicists call a geodesic. A photon doesn't feel a tug or consciously change direction. At every moment, it simply travels along the straightest line the local geometry allows. Space-time itself is bent by mass and energy, so what looks like a curved path to us is actually the photon moving in a perfectly straight line through a curved landscape. Imagine drawing a straight line on the surface of a globe. Locally, at every point, the line is as straight as it can be. But viewed from outside or flattened onto a map, that same line appears curved. Light behaves the same way. A beam of starlight passing near the sun follows its geodesic through the space-time the sun has warped. To a distant observer, the light's path appears bent. Light doesn't bend because gravity reaches out and grabs it. Light bends because the road it travels on, space-time, has been reshaped beneath it. In Newton's universe, gravity was a force acting within space. In Einstein's universe, gravity is the shape of space itself. A photon crossing the cosmos is simply following the straightest path through a curved universe, and that is why even massless light cannot escape the influence of gravity. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.